So, prototype chains. This is the whole rule about prototype chains. It's one of those you could get up and leave now type lectures. This sentence encapsulates basically everything true about prototype chains, about prototype delegation relationships. It goes like this. When a key lookup fails on an object, the lookup is delegated to that object of prototype. What is a key lookup?
When you access a property.
When you access a property, absolutely. What is a failed key lookup? With a black shirt. What is a failed key lookup? So a key lookup was property access.
I just walked in.
That's okay. I'm covering the basics. What do you think of when you hear failed key lookup on an object?
Oh, I'm fine.
Well, that's what is returned. But describe to me the event of a failed key lookup.
It goes and looks in the scope or...
Not scope, but yes. It looks in the object.
Right. I'm sorry, key. So
It looks in the collection of properties, trying to find something that has that key. And it fails because the object does not have such a property with a key like the one you're talking about. Obj.missingPropertyName is a failed lookup because based on the name of the property, it sounds like that object doesn't have it. So, whenever that happens, you go and you look at an object and it fails to find a property. Before it truly fails and returns undefined, it defers that lookup to its prototype. It works kind of like this. What's your name? Pruggan?
Yes.
If I delegate my failed lookups to Pruggan, and somebody asks me a question that I don't know the answer to, I'm going to just consult with him quietly in the background, and then if he tells me an answer, I get to pass it off as if I knew. What do you know a lot about?
Missing properties.
Missing properties. As in like you worked at a lost and found at one point? We don't have any keys, I'm sorry. So, sailing, you look like you might sail. Golfing? Poker.
I can try to advise.
Okay. What do you work on? What does your company do?
We work on business analytics.
Okay, analytics. Analytics and statistical modeling.
Sure.
Great. Somebody asked me a question pertaining to business analytics. You in the back.
How do you calculate the standard deviation?
Sorry, hang on one second. How do you calculate the standard
We
deviation?
just make index called Wolfram Alpha and Alpha Beta.
Got it. Here's a web address for Wolfram Alpha. So in this world where I don't know anything about how to compute, important statistical questions about the analytics for businesses, luckily I delegate to someone who does know that. Now someone asked me a question about, what do I know things about? It's not JavaScript. Breakdancing. Somebody asked me, well, see the thing is no one knows what to ask about breakdancing. Asked me a question about something simple, like, this is the worst thing that's ever happened to me. What's a simple topic that I'm definitely bound to know?
Colors.
What's that? Colors. Ask me about colors. Yes?
What's the difference between Cmyk and Rgb?
What is the difference between Cmyk and Rgb? Cmyk is to do with additive color, whereas Rgb is to do with subtractive. So because I know the answer to that, I was able to provide that answer without delegating. A lot of people ask questions like, well, what happens if something about questions that I do know the answer to. When a key lookup fails on an object, this relationship was not even engaged in the instance where I knew the answer. This is very much what it's like with an object and its properties. If an object has a property locally, and it can satisfy the answer, it does not consult with its prototype. But if you ask a question, and the object, if you look for a property, and the object doesn't have the property locally, it secretly, silently in the background defers to its prototype object, and then passes off the result as if it was its own. Now it's entirely possible for the key lookup to fail further up the prototype chain, At which point, Pragan would do what, do you think? What do you think Pragan would do if he didn't have that key either?
Bail out.
What's that?
Bail out.
Bail out? He would, well, so what would that look like? What would he give back to me?
Exception perhaps?
What's that?
Exception perhaps?
Perhaps an exception, but in JavaScript, when you access a property that isn't available in that object, instead of throwing an error, which would be a perfectly reasonable thing, it gives you undefined. So he could notice that he doesn't have that property either and give me undefined, and then I'll pass off undefined, which is kind of what you'd expect if there was no delegation relationship. I don't have it. Apparently, secretly, silently, my chain of prototypes doesn't have it. So I will just say undefined if neither of us knows. Interestingly, Pragan had the opportunity to delegate the failed lookup to his prototype. It goes all the way up the chain. It stops at some top level thing that doesn't have a prototype at all. Probably the object prototype, which is the sort of like granddaddy object of all objects. So all of the truth you need is contained in this sentence, but we should probably just explore the situation a little bit. Does anybody have any questions before we move on? You try to access a property, the property is either available on that object directly or it's not. If it's not, the object doesn't immediately give up. It asks its prototype object and then passes off whatever the prototype has. Yep?
You have like a real world example?
Do I? Yes. I have a real world example. Imagine there's an object that represents the president. And the president, you were setting me up. If the president knows important stuff, like what our strategy is, right? Like, we're going to look to him for stuff about how the country's supposed to work. That'd be great, because then we can go to the president and we're like, hey, president, tell me the strategy again. Peace, sweet. And we'll not launch those things. That's if you have one president and you interact directly with him. But the president maybe is overworked, and we want someone kind of like handling all of the nonsense that the president doesn't need to worry about. The president doesn't want to remember where his favorite sandwich shop is or what their phone number is. He just wants somebody, when queried, to be like, oh yeah, he really likes sandwiches from, you know, down the street, right? Let's say we hire someone to stand in the way of the president and sort of be the buffer of information so that the president is queried as seldom as possible. Here's the president. His strategy is peace. And here's Al. Al's just some guy, right? And I go to Al. Look at Al. Does Al delegate to the president? What do you think with the goatee? For some reason I love calling on people who aren't. I don't know why. It's sadistic. He's probably doing something very important, but for some reason he just stands out in my mind. What do you think Al delegates to? The object prototype. Yes. Al has not been specified to have any relationship with the president whatsoever. We certainly wouldn't want it to be the case that every new object that comes into existence delegates to the first one that we put in the president variable. That doesn't make any sense. Our programs should allow us to specify objects that don't delegate to other objects. And these object literals here, these two curly braces, that's what they do. So Al is just a person. There he is. No properties at all. If I set Al to know what the White House address is, and there's that property on Al, then when I query Al about the White House, he can say, oh, it's at 1600. But when I query Al about the strategy, Al doesn't know. Al's like, I don't know. I mean, I don't know the president personally, so I can't really speak for him, right? This is going to return undefined. These are just the rules that you expect it to be the case, right? But what if, instead of Al being a vanilla object, what if instead we created him in such a way that he would delegate? Al would delegate to the president. There is a function that you can run that will generate this relationship for you. It's called object.create. So instead of two curly braces, we're going to call object.create. I'm going to take this off the screen for a second to give you an analogy that's going to be easier to understand. Right here, this box is it's call it a transmogrifier. If we put something in the box, then we get something out that delegates to that thing. This is going to get ridiculous, guys. Mark, would you come up here? Okay, could you please crouch behind this thing? But scoot that way a little bit back. Yeah. Thanks. All right. So this is a transmogrifier. You put something in the top, and out the side, let's say out this side, turn around. You put something in the top, and out the side comes something that delegates to it. How many objects are we talking about in total in this system? 2 objects? Is that right? Close. 3 objects. We have a machine. You pass an input object into this machine, and out comes a thing. Right? Yes. 3, absolutely. All right, here we go. So, we're going to pass something in, and out comes a brand new thing. Can you point to what you delegate to? So I am the input, and here's a thing that delegates to me. This machine, this transmogrifier, generates new objects. So if you pass me in again, you stay out there, someone else would pop out, and there'd be now 2 things. I want to do it again, hang on. There'd be 2 things pointing to me. I wish I had another thing. Don't point at me twice because that's confusing. So now you can imagine there being 2 objects, both pointing to this thing that we passed into the transmogrifier twice. This little pantomime is super important to your ability to reason about this system. Everybody gets these 3 objects confused. We're all good.
Okay. Kind of reminded me of a wound.
Totally worth it. I would just do it anyway. When you guys leave, I'm going to be doing that for like an hour. So in this world, Al went from being a vanilla object to one that we get out of this transmogrifier. We passed the president in to the transmogrifier, and this transmogrifying function gave us a brand new object, Al, that delegates to the input object. Does that make sense? Are there any questions about what this transmogrifier promises?
I have a quick question. What's the difference between just saying new president, var all equals new president?
You are asking what the difference is between this and another language construct that we have not yet explored, the keyword new. Your sample code fundamentally misuses the keyword new in a way that I will go into a lot of detail about at the lecture tomorrow morning. Tomorrow morning we examine the keyword new and how it works and how it doesn't work and how people think it works and the very simple rule as to what it does. But right now I would ask that you guys table your consideration of the keyword new completely for fear that we will pollute this conversation with things that aren't necessarily needed. So here's one major realization we had in the curriculum at Hack Reactor. It's what allows us to teach the fundamentals of JavaScript. People learn it in the first 4 days. In the first 4 days, we teach people what took me about a better part of a year, maybe a little over. And one of the main realizations we had was that the keyword this can be understood completely in isolation of any other object-oriented construct in the language. And so we teach the keyword this first, and when people bring up the keyword new or prototype change, we say, let's get to that in a minute. Let's just set this in stone because it's an independent concept. We then stacked on prototype chains, which we're doing now, during which we do not need to think about the keyword new in order to fully and completely understand it. Lastly, we think about the keyword new, which requires us to understand the first 2. So these concepts are stacking, and we're going to get a lot of value out of not having to consider the keyword new while we're considering prototype chains or the keyword this. Yep?
I'm not sure if you're going to cover this, but is there a difference between object.create versus object.extend, which in my mind I thought was what you just described?
Great question. We have a function called object.extend, which, intuitively should copy the president object and make a brand new object that has all the same properties. But notice, this transmogrifier did not produce a replica of me, right? It produced a new object that delegates to me. And this is slightly but importantly different. One important difference is, with Mark standing here and me standing here, I was the input, he was the output. If I evolve over time, failed lookups to him will have an up-to-date version of my information, because he's going to delegate them to me. For the rest of his life, he is going to remember who to consult when he's queried about something he doesn't understand. But if instead we passed me into a copying machine, we would get a duplicate of my current state at copy time, and as I changed, Mark would know nothing about it. The output would know nothing about it. Object.extend would create a duplicate mapping for that moment in time, and then no relationship between the two objects other than their intense similarity at one moment in time. They would evolve independently. But a delegation relationship means that the two objects will have a relationship for their lifetime. As long as object 2 is in existence, as long as Al is in existence, he will delegate all of his failed lookups to the president, in this case. Does that make sense?
So the object.extend would, at the end of using object.extend, we would end up with 2 presidents. Is that what you're saying?
You would end up with 2 objects that share all of the exact properties that the original president did. At that moment in time, interrogating the 2 objects would look quite similar. But as the president object changes, the 2 techniques would look very different. One is a delegation relationship that follows this rule. The other is an imagined copying procedure that does what you would expect a photocopy to do. If I put notes on my original book, the photocopy doesn't change. That's what a copy is. Whereas a delegating object references the original every time you interact with it. It's like, hey, delegating object, what is your something something? And it's like, well, I either know that or I don't, and if I don't, I'm going to check with my upstream delegate. Yes?
So this still allows you to give Al, that object, its own attributes outside of what the president is saying?
Absolutely. So here we have, this is the entire in-memory model here. Al has this one property, but he delegates to president who has this other property. So if I ask Al about the White House, he says it's at 1600, that's the address. If I ask Al about strategy, it's going to fail here, fall through to the delegate, and be passed off as his own. Pop, quiz. What happens if we say president.White House?
Are you asking me?
Nope, sorry, behind you.
He doesn't know, so.
He doesn't know. He delegates where?
To object prototype?
Yeah, the object prototype. Nowhere particularly interesting. And so when we ask him about the White House, he certainly isn't going to call Al and be like, "This is very embarrassing." Right? He's going to own up. He's going to be like, "You know what? I'm the president, but I don't know." A few details, unless you have questions. Details. Delegations are created with object.create or new. Keyword new is going to be explained in detail tomorrow. Delegate objects also delegate, forming their own chain. The object prototype is that we covered all of this. For method calls, we use the rules we already learned. Look to the left of the dot. Whatever's there is what the keyword this will be bound to, even if it's found up the chain. So if you call mark.jumpamazingly, and jump amazingly is found as a property of me, then Mark will jump amazingly because he was to the left of the dot. Mark.jumpamazingly, right? Does that make sense? The keyword this will be bound using the rules we already learned. If it's a method call, you look to the left of the dot. It doesn't matter that a fall through happened and I ultimately satisfied I had the property locally. If I have the jump amazingly method and you try to access it on Mark, he's to the left of the dot at call time. Mark.jumpamazingly. We use the method invocation binding pattern. Huh? Huh. Thumbs? Keyword this, bound to the thing on the left of the dot, still. Okay, in the back.
Just to make sure I understand the difference between create and extend.
Mm-hmm.
When you extend, whatever the attributes are set at, so White House 1600 or whatever, for president, that was president's attribute. And you change that to 1800, whatever was extended would not change to 1800, it would remain 1600?
Yes, extend works very much like a photocopier. You're building a brand new duplicate that looks almost identical. It isn't identity identical. The two objects would not triple equals each other because they're different objects. Just like Al and the president are different people, even if they have all the same information available in their minds. It's a photocopy, and so the two do not track over time with one another. But a delegation relationship is a bit different. For the lifetime of the created object, it will always delegate failed lookups to the target delegate object.
Why did they choose extend the name when like would have been watching for a clone or do another one?
I think it might have been following the precedent of a few libraries. I know that jQuery had already implemented extend. I think it is not exactly a copy operation by some definitions.
Also, it takes arguments.
Extend takes one.
You can expand
One object with multiple.
yeah.
Right. Another interesting thing about extend is that you can say extend some target object with objects with all the properties from source objects A, B, C, D, and E.
And also your initial object can have junk on it too. And
Yes.
yeah, so it's not just a clone.
Right. The extend operation is even more general because
Didn't know that! Whoa!
Tony's very proud when he can think of a thing I didn't think of already. So, moving right along. So, there's no way to change or access an object's prototype. There's no way for you to know who Al is delegating to. Now, in newer versions of the language, this is less difficult to get access to. And in some engines, they preemptively implemented ways for you to find out what a prototype of an object is. But believe it or not, if I give you a random object, there is no browser-compatible way to tell me exactly what that object's prototype is, just right off the bat. No cross-browser way. Does that make sense? Can I get a show of hands? Be brave here. If you are now, or were until a couple sentences ago, under the impression that Al.prototype was president. Al.prototype, is that president? Did you think maybe it would have been? Come on. Just raise your hand to make me feel better. I thought so. Okay, a few of you thought that was the case. And a few of you, the rest of you just wouldn't admit it. Most people seem to think that a given object's .prototype property refers to whatever it's going to delegate to. That's not the case. And I would like you to imagine for the moment that there is no way for you to access the target that that object is going to delegate to. So given Mark, you would have no way of establishing that he's delegating directly to me. You certainly don't have a way to change that association. Neither of these things is possible. Now, as I said, this is evolving, and at a certain point in time, we're going to be able to do this. There's a, yes?
You can give it a debug. Because it's free on or extend.
You mean the under, proto, under?
Yeah, under the object, the prototype, you can still see its values in the learner.
In the Chrome debugger, you mean?
Yeah.
Right. So Chrome is one of those interpreters that gives you access, and in fact, you don't even need the debugger. You can in Chrome, you can programmatically read the under proto property, and you can even write to it. But by the standards, there's no way to get access to it, and there's no way to change it. Those are the old standards. New standards, I think, still don't allow changing it, but may allow finding out what it is.
So I see other code that says object.prototype equals another object.
You actually haven't, believe it or not. You have never seen code that says object.prototype equals another object. You have only seen code where you change the .prototype property of a function, which is a whole construct we'll explore tomorrow, that I'd like you to pretend you've never seen. Trust me, that can't be done to objects. It can only be done to functions, and it means something very different than anything we've discussed. It's very confusing, and it's easier if we evaluate how that works with regard to some other topic. When we understand that other topic, it'll make a lot of sense, I think. Right now, pretend as though there was no such thing as a .prototype property in the whole language at all. So, you can't get access to an object's prototype. In some browsers, they expose it at .proto. And we don't need to go over this. I would rather you guys have time to play with the exercises. There are some basically memory reasons and some class reasons that you would want to do this, but it's less interesting. So, please go, if you haven't already, clone this repo, start following through the README, or pick up where you left off on the README, and our TAs will be circulating and helping you get unstuck with any things you get stuck on. Cool. Oh, sorry.
Just one question.
Yeah.
About the lectures tomorrow.
Yes.
I can't find anything on the schedule.
Friday.
Oh, I keep saying tomorrow because in my brain, that's when it is.
Thursday, definitely.
Oh, okay.
Right. So starting at 9:30, we'll be talking about asynchronous execution and event systems. Then we'll talk about code sharing techniques. And I'm probably going to stick something in the middle of the schedule here. But stay tuned. All right. Lastly, if you were joining us today, but you won't be able to hang out with us on Friday, it's cool. We had a lot of fun. You are more than welcome to talk to me or anyone from the team if you're interested in finding out more about the classes that we do in San Francisco. We do this exact curriculum over and over again. Every 7 weeks we have a new group of people coming in for an immersive class to learn JavaScript techniques. And they come out the other side extremely effective to software engineers. JavaScript is kind of like the foundation that we pour so that we can talk about more advanced concepts like the nuances of OO versus functional programming, various design patterns and architecture patterns. So that's where we come from, and I'm more than happy to talk to you more about it or give you a flyer with more information on it. All right, so TAs, if you can wander around and see if everybody's doing all right, we'll make sure that you guys can make progress on the exercises.